welcome to video 3 of the second lecture. Today we will talk about conditional probabilities. In the last video we introduced the mathematical theory of probabilities. In this lesson we will talk about conditioning and the influences that knowing about additional information has on probabilities. How can we update probabilities given new information? So the agenda consists of the following topics: introducing conditional probability, the axioms of conditional probability, and talking about how conditional probability influences disjoint and subsets. So for us to better understand conditional probability, let's go through an example. So consider, for example, a city like Delft, where there is a probability of rain for a given month for each day of 23%. What happens to the probability of being rainy if I already know something about a certain day? Imagine that I know that for a certain day there will be more clouds than usual, so it's going to be a cloudy day. How does that influence the probability? Well, intuitively, you probably guess that because it's going to be more cloudy, that the probability of rain, given that it's cloudy, it's going to be higher than simply the probability of being rain in a general day for which we don't know nothing about. But how can we calculate, how can we estimate precisely this probability of some event, given that we have well-known information of something that will happen for sure in the future? Or in other words, as you obtain additional information, how should you update the probabilities of your events? So there's a well-known formula for calculating the conditional probability, and that will be the probability of the intersection of the two events in the same sample space over the probability of the given event that you already know that will happen. And let me just provide you an intuitions for this formula. So consider that because you know that event B will happen, so every other outcome that is in the sample space can be discarded. So the sample space gets reduced to the event B. Now the only chance that A can happen is when A is intercepted with B, because B has to occur. And for that reason you can calculate the conditional probability by dividing the probability of the intersection over the probability of B. Because you cannot divide by 0, the conditional probability of A given B is undefined when the probability of B is equals to 0. But that's okay. The probability of B being 0 means that the event B will never occur. And if B never occurs, it does not even make sense to say A given B, because B will never occur in the first place if the probability of B is 0, right? It is important to note that the conditional probability is a probability itself, so we can also talk about the axioms of conditional probability. And they are simply the axioms of classical probability with the conditioning clause. We can also relate disjoint events and subsets with conditional probability. And in the case of disjoint events, what happens is that disjoint events have an intersection as the empty set, right? So if you calculate the conditional probability, it will be the probability of the empty set over the probability of B. And in that case, it will be 0 over the probability of B, which turns out to be 0. But this is just mathematically. And intuitively, it also makes sense, because if you come to think of it, if the two events are disjoint, they can never occur at the same time. So if one happens, you are sure that the other does not happen. So trying to find the probability of the other given B, it will always lead to 0. So consider the roll of a dice. Imagine that you know that an even number will come out, and you want to know the probability of an odd number. The probability it's 0, right? Because the two events are disjoint. If you know it will come out an even number, it will never be odd, right? And that's the whole idea behind the conditional probability of disjoint events. It's always 0. And we also have the reverse case, which is subsets. For instance, imagine that B is a subset of A. Whenever B happens, A also happens. So the probability of B intersected with A equals the probability of B. If you calculate the probability, the conditional probability, you get to 1. But also consider the case in which A is a subset of B. In that case, A intersected with B equals A. So you will end up with the conditional probability being probability of A over probability of B. So the learning objectives for today are the following. We talked a lot about conditional probabilities and the consequences that it has on disjoint events and on subsets. And we also talked about the axioms of conditional probability. With all of these notions, we can now go on to talk about important rules that can be demonstrated using conditional probability, such as Bayes' rules or the law of total probability. So thank you for your attention and see you next lesson.